Hello, today I'm going to go over Le Chatelier's principle, but just dealing with concentration. And it talks about Le Chatelier's principle, but what this is there's chemical reactions that can go back and forth. And that's what we see down here when we see the double arrow. We have the arrow going both ways. That means that this chemical reaction, while it's in like a water or something, can switch back and forth, okay? So when conditions change, in this case, concentration, maybe I'm going to increase the amount of one of these molecules. So it's asking, how will the system react? How is it going to balance things out? Because we have an example up here when the concentration of a reactant is increased, so we're increasing concentration of one of these things, the system wants to put that back into equilibrium. It wants to balance it again. And it's going to do that by favoring formation of the products. So if I increase something on one side, it's going to want to increase something else on the other side. All right. Now, this nice little guide here tells us which direction that equilibrium is going to go. And that's all we're going to be doing, is drawing some arrows in here. So I think it's best to do a couple of examples. So use this as your guide for each of these. So we look at this first one, and I've got two different molecules of gas that will react to form one molecule of gas. Okay, cool. If the concentration of N2 right there is increased, so we have more of this stuff now, predict the direction in which equilibrium will shift. Okay, so N2 increased. Well, if I look at my starting materials in blue, I've increased my one of my starting materials. Well, that's going to favor the products. And this is really nice because it's color-coded. So when I increase my starting products here and there, it's going to favor the products, which are in orange. So I'm just drawing that arrow pointing towards the right. So down here, we go like that. All right, so this is gonna be your guide. Let's do the next one. Gives my equation. If the concentration of H2, which is on in this particular case, on the reactant side, if this is decreased, predict the direction of equilibrium shift. Well, I just look up here, and if I decrease one of these starting materials, equilibrium is going to shift to that same side with the starting materials. So what that looks like is just an arrow pointing this way. So take a look at each one of them. This will tell you which way the arrow goes. Sometimes I start with the products, because remember, this reaction goes both ways. So sometimes I'm going to say, what happens when I increase or decrease this thing? And it'll tell you which direction the equilibrium will shift. All right. Let me know if you have any questions. Hope this helps. Finish both pages, please.